Hi kids, today we're going to be learning about Lewis dot structures. When people bond, they say things like, "We have such great chemistry," while in actual chemistry, bonding is a big part of that too. For example, a chemical bond is basically an attraction between atoms that allow the formation of chemical substances that contain two or more atoms. The year was 1916. Scientist Gilbert Newton Lewis describes his model of a covalent bond as two atoms sharing their electrons. Part of chemical bonds is where elements come into play that you can find on your periodic table. Now let's talk about valence electrons. Chemical bonds have this thing called an octet rule, where their valence electrons must be 8 in order to be considered stable. So say this was your element. You'd fill it in this order, so according how many valence electrons it has. Say this one has 8, it's stable. Say we're taking carbon plus oxygen to get carbon dioxide. Since carbon is 4 away from the nearest noble gas, that means carbon must have 4 valence electrons. Same goes for oxygen, which is 6 away, because they must reach the noble gas section. So we've got CO2, right? So that's oxygen, another oxygen, and carbon. So in this order, we're going to be filling in how many valence electrons each has. For example, oxygen has 6, and carbon has 4. So it seems alright, isn't it? But it's not. It's actually really ugly right now, and we have to fix it so that it's stable. So let's take the 2 valence electrons up here and move them to the side to match up with oxygen's. Then we can do the same over here with oxygen and carbon, maybe the ones down here, and match these valence electrons up. This is called a double bond. Each one has 2 at the end, so representing 4 each. For symmetrical reasons, let's take away these and just put them at the side here. Now there are 2 open-end spots. But you don't need to fill in these spots in order for it to be stable, because these double bonds already represent that. Now you have an accurate Lewis structure model of CO2. And that's pretty much all you need to know.
Alright, so in this video we'll be learning about attractions between molecules. The simple attraction between opposite charges and repulsion between like charges are the driving forces behind chemical bonding. This means that properties like melting and boiling points are a measure of how strong the attractive forces are between individual atoms and molecules. Okay, so the types of attractions that we'll be learning today will be van der Waals forces and hydrogen bonds. So we'll start with the greatest intermolecular attraction, which is hydrogen bonds. So a hydrogen bond is the attractive force between the hydrogen attached to the electronegative atom of one molecule and an electronegative atom of a different molecule. Okay, so van der Waals was the guy who discovered dipole forces and dispersion forces. Now referring back to my hydrogen bonding example, the dash marks that I am making in this example are also the dipole-dipole forces, which are the attractive forces between the positive end, hydrogen, of one polar molecule and the negative end, oxygen, of another polar molecule. Now the dispersion force, also known as the London dispersion force, is a weak attractive force between atoms or nonpolar molecules caused by a temporary change in dipole movement. This creates a ripple effect, creating a similar shift in adjacent molecules and atoms.